Hi everyone, this is an ACE session, Assistance with Chemistry Examples, and here we're going to look at the problem starting with an alkyl halide, propose a synthesis for each molecule that employs a Grignard reagent and epoxide. Many times when you use a Grignard reagent, you're going to make an alcohol. Obviously the two targets are not alcohols, but we are going to go through an alcohol. That's why I call this synthesis of alcohols plus beyond, using Grignard reagents and epoxides. Before we get started with this problem, let us do a quick review of Grignard reagent plus epoxide. Let's say we take this Grignard reagent here, plus an epoxide. Let's make this epoxide asymmetrical. And I know this problem is not concerned with the mechanism, but I just want to show you where this oxygen ends up when we look at the mechanism. Before I continue, let me jot down a couple of rules that I want my students to remember. The form of the Grignard reagent that I'm using is the one with a covalent bond, and when I have that Grignard reagent attack the epoxide, I start the mechanism arrow from the carbon-magnesium bond. We're going to attack the less crowded carbon of the three-membered ring of the epoxide. It's an attraction between two opposites. This carbon is partial negative, while this carbon is partial positive. This one right here. Okay. If you are drawing the mechanism, make sure you break the correct leg of the triangle to get that dot back to 4 bonds, and we have this. We attack the dot. That dot is connected to, why don't I also number at least these 4 carbons. Okay. So we attack the dot, but that carbon number 1 is connected to 2, which is connected to 3, which is connected to 4. 2, 3, and 4. But you see, the oxygen is connected to carbon number 2, but not carbon number 1, and we have this anion, the oxide. And that's why I say that whenever you use a Grignard reagent, it's likely that you're going to form an alcohol, because after protonation, so there is a second step typically after Grignards, it's to protonate the alkoxide. Now before we look at the two targets, the other thing I want to emphasize is that, we have a functional group here, but the bond was not made to this carbon. See, the bond was made between this second carbon and this carbon number 1, right here. So that bond is that bond. So we're going to use that strategy and look at our targets and ask ourselves which bond was made, and then what kind of Grignard did we have, and what kind of what kind of epoxide we had. That's what the question's asking. Grignard reagents and epoxide starting from an alkyl halide. Okay. Oh, the last thing is, whatever a Grignard can do, organolithiums can do also. So that's an organolithium that's analogous to this Grignard reagent. Okay, enough of the review. Let's look at target number 1. So target number 1, that CHO group, you have to remember, is an abbreviation, or the condensed structure for an aldehyde. So that is the same as this. I like to draw the H, you don't have to. Okay. Well, I thought using a Grignard would give us an alcohol. Yes, but you know from Organic Chemistry 1 you could convert that alcohol into many things. An alkyl halide, an aldehyde, possibly ketone, maybe a carboxylic acid. So this came from an alcohol, most likely. An arrow that looks like this, okay, that means comes from, and it's a way to strategize a synthesis. It's called a retrosynthetic arrow. Where did this come from? Well, our guess is it came from this alcohol. Well, nuts. Where did that alcohol come from? Look at the bonding here. See, it was this bond that was made. It's between this carbon next to the carbon of the alcohol and the next carbon. Do we have that similar pattern here? So there's the carbon of the alcohol, and the one next to it is here. So possibly I had made this bond with a Grignard attacking an epoxide. You know that epoxide, the three-membered ring, is a carbon-carbon oxygen. Maybe it's these two carbons and this oxygen here. That dot is where I did the attack, or that's where I plan to attack. Now the thing is, this arrow meaning comes from, well, that's not part of this answer for the synthesis. We have to get to this alcohol and then figure out a reagent to go from this alcohol to this aldehyde. And that's going to be a matter of us remembering our Organic Chemistry 1. So the answer for this, to get target number 1, okay, they want us to start with an alkyl halide. So we have to start with alkyl halide and make the Grignard reagent. Well, if that's the bond I think I'm making, and that's the dot I think I'm attacking, my Grignard has to have these 6 carbons. And the Grignard came from an alkyl halide, for instance, this bromocyclohexane. Make sure you know what kind of formatting your professor wants when you do a synthesis. I'm going to use full arrows here. Really, not many of these reactions are reversible. And you draw the product of each reaction, and you're linking up a set of reactions to get to your final target. Now the epoxide I'm going to use is the simplest epoxide, oxirane. I'm going to attack this dot, and I get the alkoxide. So here's the dot. Oh no, that's not the dot, right? See, it's this carbon attacking this dot, so it's this carbon attacking this dot. That's the dot right there. We do have this carbon next door, and that carbon has the oxygen. Okay. Now, let me show you, well, I'll do the shortcut on our next target. I was going to combine under the same arrow the epoxide step and then the protonation step, but I'll do this separately for this example here. You could use H3O+, and we have this. And that's what our strategy was asking us to do, to make this alcohol, same alcohol. Got to remember your oxidations from Organic Chemistry 1. This is a primary alcohol. And we want to stop at the aldehyde. We don't want to over-oxidize to the carboxylic acid. Remember PCC? PCC oxidizes primary alcohols to the aldehyde. I'll draw it like this. Okay, that is our target number 1, right there. And it is the aldehyde. That represents a good answer for the synthesis for target number 1. For target number 2, my retrosynthetic arrow is going to lead to an alcohol that I think I need to make to eventually get to my target. Right, and then we'll have to think of a reaction that goes from here to there. But if I can make this alcohol using the Grignard reagent and an epoxide, I think the synthesis will work. The strategy is, again, there's your alcohol. Here's a carbon next door, and here's a carbon next door. Well, obviously we didn't attack this carbon because there's nothing on it. Right? We attacked this carbon. It looks like we're using the same alkyl halide, but obviously something has to be different because this molecule that we first made doesn't have this methyl group. Okay, so let me go ahead and make the Grignard reagent again. Sometimes your professor may want you to put the solvent. Remember, it has to be a dry, aprotic solvent. Now let me show you something that I will allow my students to do. If one of the reactions is a protonation, in the synthesis, I would allow them to do that protonation under or above the same arrow as the previous step. So let me show you what I'm saying. Oh, well, this is going to be a little bit trickier. Let me put the protonation right now so I don't forget. That's what I mean. But I need an epoxide. We'll take a look at the stuff on the right of this dotted pink line. It has 3 carbons, right? I have a dot for sure, but I have to have this methyl group somewhere. Let's see if this works. What if the methyl group's there? Well, there's only... It would be the same molecule if I put the methyl group here. But let's double check if this epoxide would give me this correct product. If I attack this dot, that bond will open up, and that oxygen will be on the second to last carbon. Okay, so I got the same molecule. I attack the dot, that oxygen stays on this carbon. I still have this methyl group. Okay, you could, if you want to, you could number the epoxide just to make sure you have everything there. I have this protonation step. So there's my alcohol. Like I said, if there's a protonation reaction in your synthesis, you can put it with either the preceding reaction or the proceeding reaction. But it makes sense to put it here, right? There's your Grignard going into an alcohol. And now we need an oxidation. We use PCC. Again, this is a secondary alcohol. And so PCC will oxidize the secondary alcohol to the... What is that? That's a ketone. Okay. And we have our target. We're done with this synthesis. Okay. Again, that's a ketone. Or you might recall Jones oxidation, which is chromic acid oxidation. Many times chemists will use a combination of K2Cr2O7 with H2SO4, and within the round bottom flask, chromic acid is made. Chromic acid is, I could write it here, H2CrO4. So any of those three reagents will do the oxidation of a secondary alcohol to a ketone. Make sure you practice, and when in doubt, go ahead and try a simple example, just to remind yourself where that oxygen ends up when the epoxide is attacked and opened up.